So now we're going to look at the pH of strong acids and bases. Okay, so let's start with the question. Okay, it says that we want to find the pH of 0.1 mole per dm cube, 0.1 mole per dm cube hydrochloric acid. When we talk about HCl, right, hydrochloric acid is a strong acid, right? So in aqueous solution, HCl will ionize completely to form H plus and Cl minus ions, right? So if I have 0.1 mole per dm cube of this, right, we're assuming that all the acid will ionize, so we'll form the same concentration of H plus ions, right? Because for every mole of HCl, you're going to form 1 mole of H plus ions. Again, it's a strong acid, it ionizes completely. Now, if we talk about aqueous hydrochloric acid, right? If we talk about aqueous hydrochloric acid, right, we have HCl aqueous, right? So in this is HCl is dissolved in water. HCl is dissolved in water, right? So we also know that water also ionizes. Water also ionizes to form H plus and OH minus ions. Now, there's a few things to note here. First of all, that if we just had pure water, right, the concentration of H plus ions is 10 to the power of negative 7, which is 0.0000001, right? So whenever you add something like a strong acid, right, to water, you can assume that all the H plus ions are coming from the acid. You can assume that water is such a small contributor to the concentration of H plus ions, right? So few H plus ions are coming from water, okay? You can assume that this is negligible, right? So you can ignore the concentration of H plus ions coming from water. You can assume all the H plus ions are coming from the acid. The other thing to note is that this is for pure water, right? When you add H plus ions here, right, what you do is you actually increase the concentration of H plus ions significantly by adding the acid, which means that this equilibrium shifts to the left. You're significantly increasing the concentration of H plus ions, which means that this equilibrium shifts to the left. Now, even the shift barely affects the concentration of H plus ions because it's such a large amount of H plus ions relative to what you would see in water that we can say that the OH minus concentrations changes significantly. However, the H plus concentration is still taken to be the same as we get from the acid. Okay, so Kw is still a constant. Okay, this product remains constant. What we're saying, because again, this equilibrium still exists in aqueous solution. What we're saying is that by adding a strong acid here, we've significantly increased the concentration of H plus. Therefore, we've significantly decreased the concentration of OH minus. But as long as the temperature is constant, right, the product of H plus and OH minus ions will always be a constant because the equilibrium constant is only affected by temperature. So increasing H plus means that OH minus concentration decreases significantly. All right. So what that means is that in this particular solution we have a much larger concentration of H plus ions and a much lower concentration of OH minus ions, but the product of the two is a constant. So the idea here is that we can assume that the concentration of H plus ions here can be assumed to be coming directly from the HCl. Whatever concentration of HCl we have, right, for every mole of HCl we produce 1 mole of H plus ions. We can simply assume that the concentration of H plus ions here is equal to 0.1 mole per dm cube, which means that the pH is just the minus log of H plus concentration, which is minus log of 0.1, and therefore the pH comes out to 1. So the pH of 0.1 mole per dm cube hydrochloric acid is just 1. All right. So let's move on to the next question. Right. Now the question is saying, find the pH of 1 mole per dm cube sulfuric acid. So over here, right, sulfuric acid is H2SO4. Okay, it is a diprotic acid. It has 2 protons. Okay, and we can assume that it ionizes completely. We can assume that it ionizes completely to form 2 H plus ions and SO4 2 minus. So if I have 1 mole per dm cube of sulfuric acid, right? However many moles of sulfuric acid I have, I'm going to have twice the number of moles, right, in the same solution. So twice the number of moles per dm cube, right? That's double the concentration of H plus ions. So again, the pH. Again, we can assume that all the H plus ions are coming from the sulfuric acid, and we can also assume that the H plus ions from water or the equilibrium of water has very little effect on the concentration of H plus ions. So we can say that the pH is minus log of H plus, which is the minus log of 2, and that comes out to negative 0.301. So first off, what we see is a negative pH. Okay, so it's important to understand that the pH scale does not have to be between 0 and 14. Okay, it does not have to be between 0 and 14. Okay, whenever the concentration of H plus is greater than 1 mole per dm cube, okay, when it's greater than 1 mole per dm cube, the pH will actually be less than 0. When the concentration of H plus ions is equal to 1, then it's 0, right? When it's less than 1, it's greater than 0, and when it's greater than 1, the concentration of H plus ions is greater than 1 mole per dm cube, the pH will be less than 0. So you can have a negative pH, and you can also have a pH greater than 14. So both of those things are possible. Now here we've actually assumed that sulfuric acid ionizes completely, but in actual fact, okay, sulfuric acid is a diprotic acid. Okay, it's a diprotic acid means it has 2 protons, okay, and it has 2 separate ionizations. It has 2 separate ionizations. In the first stage, what we have is H2SO4 ionizes completely to form HSO4 minus and H plus ions. And then in the second stage, those HSO4 minus ions that we have, right, those HSO4 minus ions that we have ionize partially to form H plus ions and SO4 2 minus ions. So if, for example, in this question we said we were starting with 1 mole per dm cube, sulfuric acid, right? So that, first of all, it is a strong acid, so it will ionize completely to lose a single proton. That will be the first ionization, because it's losing 2 protons, right? It's a diprotic acid. The first ionization, or the first proton that it forms, is complete. That first stage is complete ionization. So if I start with 1 mole per dm cube sulfuric acid, right, I'm going to form 1 mole per dm cube HSO4 minus and 1 mole per dm cube H plus. The second ionization is when this HSO4 minus that forms ionizes partially. It ionizes partially. So here in the first stage, we formed 1 mole per dm cube. HSO4 minus in the first stage. That will ionize partially. So the concentration of H plus ions will actually be less than 1 mole per dm cube. The concentration of H plus ions will actually be less than 1 mole per dm cube. Okay, because HSO4 minus here is actually a weak acid. HSO4 minus is actually a weak acid. So what you realize here, is that the concentration of H plus ions, right, will be less than 2 moles per dm cube and greater than 1 mole per dm cube. Okay, the concentration of H plus ions will be less than 2 mole per dm cube and greater than 1 mole per dm cube, right? If we're starting with 1 mole per dm cube sulfuric acid, right, the first ionization will be complete ionization. So you're going to form 1 mole per dm cube of H plus ions, but then that 1 mole per dm cube of HSO4 minus will only ionize partially. So in the second stage, you're going to form less than 1 mole per dm cube of H plus ions. So the sum is greater than 1, but less than 2. Okay, so from 1 mole per dm cube sulfuric acid, you won't actually form 2 moles per dm cube of H plus ions. Okay, so the reason why is because, right, the reason why we have this is because the second ionization is partial. The reason why you have this is because the second stage of the second ionization process, right, is a partial ionization. Now again, in a question, if they just give you a question like this, right, to find the pH of a certain amount of sulfuric acid, you can just assume that it ionizes completely. But sometimes a question may ask that why is the concentration of H plus ions less than 2 moles per dm cube? If I have 1 mole per dm cube sulfuric acid, why is the actual concentration less than 2? You've calculated as 2, but why is it actually less than 2 and greater than 1? So you should know that the second ionization is a partial ionization. Exactly. Okay, the second ionization, right, is partial, or you can say the HSO4 minus ionizes partially. Okay, and therefore 1 mole per dm cube of HSO4 minus ions do not give you 1 mole per dm cube of H plus ions. Again, similarly, if they give you just a question like this, you can assume that ionizes completely, but sometimes in the question, they can ask you two things. I'll repeat this. They can ask you two things. They can either ask you to explain why this is the case, why the actual concentration is less than 2 if you're starting with 1 mole per dm cube, or they can actually give you these two equilibria and then ask you to calculate the pH. For that, they're going to give you relevant information in the question. It's still considered a strong acid because we do have complete ionization of sulfuric acid when it loses a proton. Right? It does completely ionize to form protons. Okay, that first step is complete ionization. The second stage, which is the ionization of HSO4 minus, is partial ionization. The sulfuric acid is still a strong acid, whereas HSO4 minus here is actually a weak acid. The next question that we have here is find the pH of 0.136 moles per decimeter cube barium hydroxide. So over here we have barium hydroxide, which is a strong base. Remember, group 2 hydroxides are strong bases, right? And it ionizes completely to form an alkaline solution. We have Ba2 plus and 2OH minus, right? Now over here, our concentration of barium hydroxide is 0.136 moles per decimeter cube, which means that the concentration of barium hydroxide is this. That means concentration of hydroxide ions is 0.272 moles per decimeter cube. Because for every mole of barium hydroxide, we form 2 moles of hydroxide ions. Now again, it's important to remember that we have an aqueous solution of barium hydroxide. Whenever we have an aqueous solution of a substance, it means that the following equilibrium also exists within that solution, right? Now we know the concentration of OH minus ions. We want to find the concentration of H plus ions. We want to find the pH, okay? And we're going to assume that the temperature is 25 degrees Celsius. So we're going to assume that the temperature is 25 degrees Celsius. At that temperature, we know that the Kw, which is the concentration of H plus times the concentration of OH minus, is equal to 10 to the power of negative 14. Okay. Now over here, what we've done is we've significantly increased the hydroxide ion concentration. Which means that this equilibrium will shift to the left, right? The hydroxide ion concentration has been significantly increased. That means the H plus concentration will significantly decrease. Now, even this equilibrium shifting to the left will barely affect the concentration of hydroxide from the barium hydroxide. Again, this is such a large amount relative to this equilibrium. These are such tiny changes that there will be a significant effect on the H plus concentration, but no significant effect on the OH minus concentration. So you can assume that the concentration of OH minus is 0.272 moles per decimeter cube, whereas the concentration of H plus has now significantly decreased because the product of the two will still be 10 to the power of negative 14. Okay, so in any aqueous solution at 25 degrees Celsius, this product will always be 10 to the power of negative 14. So we can say here, we know that this is Kw, right? And we want to find the concentration of H plus ions. We want to find the pH. So let's call that X. I know the concentration of OH minus is 0.272, and the product of the two is equal to 10 to the power of negative 14. So then what is the concentration of H plus ions? That's your X here. So this is equal to, right, 10 to the power of negative 14 divided by 0.272. So we get 3.68 into 10 to the power of negative 14 moles per decimeter cube. So then we can say that the pH is equal to the minus log of the concentration of H plus ions. So that is the minus log of 3.68 into 10 to the power of negative 14, and the pH comes out to 13.4. So our pH is 13.4. Now there's another way to solve this. There's another way to solve this as well. We know that the concentration of OH minus ions in the solution, right, because it's coming from a strong base, we can just say that it's 0.272 moles per dm cube. So we can first find the pOH. The pOH is simply minus log of the concentration of OH minus ions. So that is the minus log of 0.272, right? So therefore we get the pOH as 0.57. Now we know that in aqueous solutions at 25 degrees Celsius, right, pH plus pOH is equal to 14. So we know that the pH plus 0.57 is equal to 14, and that gives us pH is equal to 13.4. So we get the exact same answer. So if you know the concentration of hydroxide, you can first find the concentration of H plus ions and then the pH, or you can just find the pOH and then the pH. This expression pH plus pOH is equal to 14 is derived from the ionic product of water at 25 degrees Celsius. The next question that we have here says that 50 centimeter cube of 0.2 mole per dm cube, 0.2 mole per dm cube sulfuric acid, okay, is mixed with 75 centimeter cube of 0.4 mole per dm cube sodium hydroxide. Find the pH of the resulting solution. So the first thing we're going to do here is we're going to make the equation, right? We have sodium hydroxide reacting with sulfuric acid, right? And we have two H plus ions here, so we're going to need two OH minus ions, right, for neutralization. And our product is sodium sulfate and 2H2O. So here's the equation. So here, the first thing we're going to do is we're going to calculate the number of moles. The number of moles of sodium hydroxide, okay, is the concentration times the volume. Concentration is 0.4 moles per decimeter cube. The volume is 75 centimeter cube. So the number of moles is, here we get 0.03 moles of sodium hydroxide. We get 0.03 moles of sodium hydroxide. Okay. Similarly, the number of moles of sulfuric acid is equal to the concentration, that's 0.2 times the volume, which is 50 over 1000. So we get 0.01 moles of sulfuric acid. Now over here what we can say is, right, that sulfuric acid is the limiting reactant, right, and sodium hydroxide is in excess. Because we have only 0.01 moles of the acid, we need 0.02 moles of sodium hydroxide to react with it. So once these 0.01 moles react, right, these 0.01 moles will react completely. So you have 0 moles of acid left over, and those 0.01 moles will react with 0.02 moles of sodium hydroxide. So you're going to have 0.01 moles of NaOH left, right? So this is the excess NaOH, right? So again, H2SO4 is the limiting reactant and sodium hydroxide is in excess. So over here we can say that we have 0.01 moles of NaOH left over, okay, and we have a solution that has volume 125 centimeter cube, right, because we mixed this 50 cm cube and 75 cm cube solution together, right. So we have 0.01 moles of NaOH and 125 cm cube of water. Okay. So we can say over here, if you look at the ionization of NaOH, right? NaOH ionizes to form Na plus and OH minus. We know if we have 0.01 moles of this left over, that means we have 0.01 moles of hydroxide ions produced. Okay, again, we can assume that the concentration of hydroxide from water is negligible. All the hydroxide is coming from NaOH, right? So this is the number of moles of hydroxide, and the volume is 0.125 decimeter cube, right? That's 125 centimeter cube. What's the concentration of hydroxide ions? Number of moles per unit volume, so that's 0.01 divided by 0.125. So we get 0.08 moles per decimeter cube. So now that we know the concentration of hydroxide ions in the solution, we can find the pH. We can find the pH here. We can say that the pOH is equal to minus log of 0.08. So the pOH comes out to 1.1. And we're going to assume that this process is taking place at 25 degrees Celsius. Again, okay, by default you assume it's 25 degrees Celsius unless otherwise stated. All right. So we know that at 25 degrees Celsius, right, the sum of the pH and pOH is equal to 14, and that implies that the pH is equal to 12.9, right? So that's your final answer.